Hi everyone. Good morning. I'm here. Thank you for everyone for being here. Let me present myself. I'm Satwinder Singh, working for Banca Sella in the innovation team in the role of blockchain specialist. Today I'm here to present you a tool that can help technical professionals and also the companies to choose a blockchain in the informed decision to choosing a blockchain, because we have a lot of blockchain in the market today, and it's very hard to find the right blockchain in base of technology, base of the economics and the governance model. And here, what I'm going to share with you is a tool or a matrix. We call it ABC of choosing a blockchain that can help you to make an informed decision about that. Let's start. Okay. Before start with the technical variables, let me introduce you what we analyze, which variables we analyze to make this matrix. We take three macro categories of variables. That's our technical variables, economics, and governance. Let's start with technical variables. Here you can see, I think all in this room know what is the trilemma. And about the trilemma, we analyze the three main variables. That's our security, scalability, and decentralization. For each of that, for example, for the security, we have the sub-variables, that is data confidentiality, integrity, availability, and consistency. And also about the security, we have the quantum resistance. And about the scalability, we take in consideration three variables: throughput, latency, and time to finality. Throughput is a TPS, transactions per second for the blockchain. And for latency, we have the time that blockchain require, that's the time required by the node to transfer the information from node A to node B. And the last one is the time to finality, is time required by the blockchain to finalize your transactions. And about the decentralization, we take in consideration also three variables: number of nodes, consensus algorithm, and fairness. About the fairness is the stake required to become a validator on the blockchain. And other two macro category of variables are network architecture, that's be public, private, or permissioned or permissionless, and flexibility, where we have a programmability of the network. That's for the programmability. What is the programmability for the blockchain? It's not just depending on the programming language. That's the programming language can be a high-level language or low-level language like C or assembly. And also it's very important the community of the developers, because the way you can find the documentation about the blockchain or about the language you are using for the smart contract, it's also very important, because if you have a big community of developers, that means you also have standards, audited standards you can use for create your business on that blockchain. Configurability, I give you just one example, because about the configurability we can talk about more than 1 hour. The configurability here, example, the configurability is the possibility to prioritize your transactions, because not all the blockchains allowed you the possibility to prioritize your transaction. Some blockchains using a fixed priority for each transaction. And the last one is the interoperability. Interoperability is a huge topic in the last 4 and 5 years. I think everybody in this room know what is it. And now switching to the other two macro categories of variables, economic and governance. About the economics, we take in consideration the native token distribution. That's mean insider allocation, how many native token was allocated for the insiders. And if that blockchain has a non-profit foundation. And the last three is how the private sale, airdrop, and public sale was managed by that blockchain. And talking about the capitalization, it's also important. Here we're taking in consideration just the three variables: market cap, total value locked. Total value locked inside a single blockchain, that's mean also on the DeFi built on top of that blockchain. And the last one is the circulating supply. And in the last variables for the economics, we have the transaction cost. We put these variables here because it's very important for the business you are going to build. Because I give you an example. If I want to create a retail payment application, for me it's very important to take in consideration how much are the transaction costs, because to make my business also sustainable in the future. And the last macro variable is the governance. That we can classify it in two macro categories, decentralized and centralized, where the centralized governance is usually used by the private network or permissionless network, and the decentralized it's used by public and permissionless network. Also, the decentralized governance can be classified in on-chain and off-chain, because some blockchain prefer to use the community forum or off-chain voting systems, and other chains prefer to use an on-chain voting system, DAO or whatever. Now, we can classify all these variables in two macro categories. Measurable variables, that are quantitative variables, and you can see it here on the slide. And we have the non-measurable variables, and that's we are interested to classify that one, because it's very hard to make quantitative the quality variables or the new measurable variables. And what we're going to do in the next slides is try to build a matrix to find a way to measure the non-measurable variables. Okay, let's start to definition of the evaluation criteria we're going to use for evaluate the non-measurable variables. Here you can see in the first column we're going to assign a grade or vote. That means if we want to analyze the confidentiality for the specific blockchain, we have the grade where the grade 1 is the lowest and the highest one is the grade number 3. What does it mean? If I'm analyzing one specific blockchain, I'm going to make a research about the data confidentiality on that blockchain, and the data confidentiality on that blockchain is cannot be guaranteed because data masking mechanism cannot be applied. In that case, I'm going to set up the vote or grade for the confidentiality for that specific blockchain at 1. In the last row, you can see the weight. Weight is a subjective value that's assigned in base of your business and what you want to build. In that case, if I'm going to build a retail payment solution, in that case, for me, one of the most important variables is the cost of transactions. In that case, I'm going to assign weight 3, that's maximum weight, to that variables. Example, quantum resistance, it's not important for me now, at the moment, and I'm going to assign vote number 1. This is some example of how to evaluate non-measurable variables. Proceeding to the next slide, we have the final evaluation matrix. We have a lot of numbers here. I try to explain in the best way I can. Here we have two blockchains. We want to analyze two blockchains for the difference, the variables, non-measurable variables, but also the measurable variables. Here, for the first blockchain, you can see the confidentiality is 2. What does it mean? It does mean confidentiality can be guaranteed by appropriately implementing data masking mechanism. That means in the phase of the development, we need to care about how we can mask the data before save that data on chain, because we know everything on chain is public and we can't save some sensitive data on the blockchain directly. In that case, we need to apply some mechanism, data masking mechanism before save that data on chain. And here we have vote grade number 2 for the confidentiality about the blockchain number 1. The first row, where we have 2 for the confidentiality, integrity 1, and quantum resistance 3, it's a objective vote. That means it's not depending on the business I want to build on that blockchain. The second row, where we have 4 for the confidentiality, 3 for the integrity, and 3 for quantum resistance, we're using a weighted value. What does it mean? We take the objective vote, that is 2, multiply for 2 the weight, the importance for our business is that variable, and we have the final vote that is 4 in this case. And in the end of the day, what we have? We have the votes for objective vote and the weighted vote, and the final vote is the average just between 6 and 10 in this case. And in the end of the day, we have a ranking of the blockchain that is more fitting with our business, and and the other blockchain that's not fitting with our business or what we want to build on that blockchain. Switching to the last slide, that's a conclusion. The scope, the reason we build this metric is because we have a plateau of a lot of blockchain in the market, and it's very hard to choose the specific blockchain where we can start our business. Usually, it's not the best way to choosing a single blockchain, but for cybersecurity risk and also to avoid some informatic risk, is the better choice is to choose more than one blockchain, and also to have an internal ledger in the backup solution. But what the objective evaluation, why that is important? Sorry, because with a plethora of the blockchains, the option we need to analyze each blockchain in the objective way and not in the subject, not in base just our business. And the second one, we need to future-proof our decision, because the blockchain we're choosing today have impact in the future on our business, and make it very important for us to make it sustainable in the future, and also adaptability and to grow our business also. And the last one, the final truth, the world of blockchain is dynamic and filled with promise. While it's easy to get overwhelmed by choices, and for this reason, it's very important to create a structured way to choose a blockchain. And that's it. Thank you very much for the attention. And if you have any question, let me know.
All right. First of all, thank you for your presentation. I want to share that I believe that what you're trying to do is really, really hard to compare different blockchains. But I would focus on the decentralization aspect, because I think it's one of the less, or the most subjective, probably. And my question is, when you say number of nodes, you mean number of full nodes, number of consensus participating nodes?
Validator nodes. Validators nodes. Because full nodes is just storage. And it is important in the decentralization. I think the most important type of node is the consensus node, because that's going to validate your transaction. In that case, if we have just 3 validator nodes, in that case, it's very easy to manipulate the network.
Yeah, I mean, full nodes are still executing all transactions, so they're still very important. But anyway, about fairness, I didn't fully get, is this talking about the stake distribution, like Nakamoto coefficient gets inside that bucket, Gini coefficients, they go there? Like, how many nodes do you need to collude?
The fairness is how is the difficult to participate as a node validator in a specific blockchain. Example, if you want to participate in a specific blockchain and you need 2,000K of dollars, in that case, the fairness is very high, because not everyone can participate in the consensus algorithm and also create a node for that blockchain, and you have a wall before you can enter to participate in the consensus algorithm in that blockchain. Other blockchains also, they don't have fairness, but in that case, they have the consensus algorithm that's operating in different way. Some blockchains need a high fairness, just for avoid the people who want to try to, the people who don't want to operate in a right way, they want to, like scammers. To avoid that, maybe fairness is good, because if you have a stake, you have something to lose if you operate not in the correct way. But also in the other blockchains where the consensus algorithm is different, example, pure proof of stake, in that case, some blockchains are not using a fairness. In that case, but the algorithm is operating to give to all the people the possibility to participate in the transaction validation just for one token in stake. But there the point is, usually the validator are selected in base of the amount of tokens they put in the stake. It's the consensus algorithm and fairness are highly correlated, because you can't just analyze consensus algorithm and the fairness by themselves. You need to analyze it's together, usually.
So there is no metric on the stake centralization, for instance. Imagine 2 networks are the same, but in one case, one entity controls 33% of the stake. In another case, it controls 5%, the maximum. They get the same score in decentralization.
No, in that case, no. This is the reason why I'm talking about consensus algorithm and fairness will be analyzed together. Okay. Because if the fairness is low, that means maybe the consensus algorithm give the possibility to centralize the transaction validation because the fairness is low. Usually, when the fairness is low, you can participate to the network with just one token. You can have also, it's depending on the blockchain. Some blockchain have a validator routing system. They not select the same validator more than 3 times or something like that. But you have to analyze these 2 variables together to avoid this your affirmation. I don't know if I answered your question.
No,
if you want, we can
continue
discuss.
offline.
Okay.